Something strange has happened in our solar system. The mysterious interstellar object known as 3I has reached its closest point to the Sun, what scientists call perihelion. But instead of behaving like any known comet or asteroid, it did something that no one expected. It went completely silent. For months, astronomers had been tracking this strange visitor from beyond our solar system. They believed it would behave like a normal comet, heating up, releasing gas and dust, forming a bright glowing tail. That's what always happens when icy objects approach the Sun. But 3I refused to follow the rules. On October 29th at exactly 1400 hours Universal Time, 3I passed just 0.7 astronomical units from the Sun. That's even closer than Earth's orbit. At that distance, the Sun's radiation should have blasted its surface, making it shine brighter and brighter. Every major observatory was ready to capture the event. NASA's Solar Dynamics Observatory, the European Solar Orbiter, and ground-based telescopes all around the world. Everyone expected a show of intense activity. But instead nothing. In fact, the object began to dim. Its brightness dropped by more than 40% in just 6 hours. Its coma. The glowing cloud around a comet started shrinking instead of expanding. The activity stopped. Completely. For the scientists watching, it was like seeing a fire suddenly turn into ice. Nothing about it made sense. At perihelion, every known comet becomes more active. The Sun's heat vaporizes frozen gases. The surface erupts with jets of dust and vapor. But this object didn't heat up, it shut down, as if it knew it was being watched. Dr. Robert Work, from the University of Hawaii, said in an interview, "It's as if the object detected the sunlight and decided to turn itself off. That's not how natural bodies behave." This statement shook the scientific community. Rocks and ice can't make decisions. They don't have systems or controls. But what if this object isn't just rock and ice? What if it's something more? As astronomers studied the new data, the mystery deepened. Spectroscopic readings, which show the chemical makeup of an object by analyzing light, revealed something never seen before. Normally, comets show clear chemical signatures: water vapor, carbon dioxide, carbon monoxide, and organic compounds. But at perihelion, 3I showed new emission lines, light frequencies that didn't match any known molecules. There were complex hydrocarbons and nitrogen compounds that we've never observed on any comet. And stranger still, there were signals that didn't match anything in our chemical databases. Scientists compared them with every known natural material, every asteroid, every meteorite ever studied. Nothing matched. The wavelengths didn't fit any molecule we know. That means we were either seeing new chemistry never observed in space, or something that wasn't chemistry at all. Some researchers began to wonder, could these signals come from artificial materials? Metals, composites, or alloys made by technology, not nature? The question hung in the air like a shadow no one wanted to name. Then came the infrared data, the heat map of 3I. It made everything even more confusing. When a natural object gets close to the Sun, its surface heats unevenly. Different parts of rock and ice absorb sunlight differently. Some regions get hotter, others stay cooler. You always see temperature variation, but this object's temperature was perfectly uniform. From pole to pole, from front to back, the same temperature everywhere, no hot spots, no cold spots. That's impossible for a natural object, unless it's made of one single, uniform material, or unless it has an internal system that manages heat evenly. That second idea sent chills down the spines of astronomers. To keep a constant temperature across an entire surface, something inside must be moving heat around. Maybe with liquid flow or active cooling systems. That means technology, and if that's true, then 3I might not be a comet at all. It might be a machine. More strange data arrived soon after. The object's albedo, its reflectivity, or how much sunlight it bounces back, suddenly changed. It doubled in less than 8 hours. No natural object has ever done that. Surface reflectivity depends on material composition and texture. It can only change slowly, over long periods, unless the surface itself is being replaced or covered. It was as if 3I repainted itself. It became brighter while its activity decreased. Normally, comets get brighter because they release more gas and dust. Here, the opposite happened. The brightness increased while the object became quiet. Some scientists suggested that the surface might have restructured, as if panels or reflective layers unfolded. This would explain the higher albedo and lower activity. Certain materials, like electrochromic coatings, can change reflectivity using electric current. We use similar technology in smart windows and display screens. But that's human engineering. Nature doesn't do that on its own. Then came the most shocking data of all. NASA's Parker Solar Probe detected a magnetic field anomaly near the object. Comets usually have weak, chaotic magnetic fields created by ionized gas. But this was different, a structured, organized magnetic field, pulsing every 4.7 seconds. Magnetic fields like this require electric currents, electricity flowing through conductive material. But a natural comet can't generate that. Only something with active systems could. A pulsing field suggests cycles of power or communication. It was as if AIvoice was sending signals. Scientists at NASA couldn't explain it. They checked their instruments for errors. None were found. They recalculated distances, field strengths, signal delays, still the same. The magnetic pulses were real, and they were repeating with clockwork precision. At this point, even the most skeptical researchers began to whisper the unthinkable. Could this be a probe? A visitor from another civilization? The idea sounded like science fiction, but the data didn't lie. Here was an object from beyond our solar system, a visitor that changed its surface, controlled its temperature, emitted unknown signals, and altered its path through space without visible propulsion. Yes, its trajectory also changed. During perihelion, its orbit deviated by nearly 800 kilometers from its predicted path. That's enormous. The models were precise, the calculations correct. The only explanation was that the object moved on its own, but there was no outgassing, no jets, no visible thrust. It just moved. To change direction in space requires force. Where did that force come from? Not gravity, not pressure, not solar wind. It was as if AIvoice made a small, controlled maneuver. That realization hit NASA's control rooms like thunder. The implications were enormous. If true, it would mean that something, or someone, built this object. Dr. Elena Cross, an astrophysicist at ESA, put it this way: either this is the strangest natural object ever seen, or it's not natural at all. What if this comet isn't a comet? What if it's a vessel, a probe, built to survive star systems, study suns, and collect data? What if it just performed a planned maneuver near our sun? Some scientists believe that if AIvoice is artificial, it could be using perihelion to harvest solar energy, converting radiation into power. Others think it might be observing the sun, gathering data like we do with our own probes. Or perhaps it's damaged, a relic from a civilization that no longer exists, still carrying out old commands. The truth is, we don't know. But every new observation adds to the mystery. Right now, NASA maintains the official position: AIvoice is a natural interstellar object with unusual behavior. But behind closed doors, not everyone agrees. Whispers are spreading through research centers, quiet meetings, encrypted emails, late-night discussions between scientists who are too afraid to speak publicly. They're asking the same question that we all are: what if we're not alone? Because everything AIvoice has done, the shutdown, the temperature control, the albedo change, the pulsing magnetic field, the orbital deviation, looks less like nature and more like design. Still, caution dominates. No one wants to make an extraordinary claim without extraordinary proof. But some evidence is simply too strange to ignore. Could this be the first real evidence of extraterrestrial technology? Could this object be the interstellar equivalent of a Voyager probe? Ancient, wandering, carrying data from a civilization that vanished long ago. If that's true, then we might be looking not just at a rock from another star, but a message, a silent machine still following its last orders millions of years later. As it drifts past the sun and heads back toward the outer solar system, telescopes continue to follow it, frame by frame. Every flicker, every spectral line, every shift in motion is being analyzed. And yet, the more we learn, the less we understand. It's almost as if three-eyed AIvoice is testing us, showing just enough to make us question, but never enough to prove anything. A puzzle designed to measure how far our curiosity and intelligence can go. Whatever it is, one thing is certain. Three-eyed has changed the way we see the universe. It has reminded us that space is not just empty darkness. It's full of mysteries waiting to be uncovered. And maybe, just maybe, we've already been noticed. As three-eyed moved away from the sun, something even more mysterious started to happen. The object didn't behave like a cooling comet. Normally, when a comet passes perihelion, its closest approach, it begins to lose activity slowly. The gas and dust fade, and it becomes a dim, quiet speck heading back into the cold darkness of space. But this one didn't fade in the same way. Instead, it changed in ways no one could explain. Over the next 48 hours, observatories detected new signals. The brightness fluctuations weren't random, they followed a pattern. A rhythm, a cycle that repeated every few minutes. To some scientists, it looked like rotation, but others noticed something stranger. The timing didn't match any normal spin pattern. The light intensity was pulsing in a regular sequence, almost like code. NASA's deep space tracking systems picked up faint radio emissions at extremely low frequencies. They were weak, almost buried in cosmic noise, but they matched the timing of the light fluctuations. Coincidence? Maybe. But when two completely different instruments record the same pattern, it usually means something real is happening. Dr. Hiroshi Tanaka from Japan's National Astronomical Observatory said, "It's like the object is talking in two languages, light and radio. What could cause that?" Natural explanations were proposed, maybe rapid jets of gas creating rhythmic flashes, maybe rotational wobble, but none of the models fit the data perfectly. Each simulation failed to reproduce the timing and the exact frequency of the changes. And so the question returned, is this object responding? Around the same time, new high-resolution images were released by NASA and the European Space Agency. These were taken during perihelion by solar telescopes. At first, they looked like fuzzy specks. But after deep filtering and contrast analysis, something remarkable appeared. The surface of three-eyed wasn't smooth like ice or dust. It showed structured geometry, repeating patterns, parallel ridges, and symmetrical lines. These features looked almost engineered, like panels or grids. At first, image analysts assumed these were artifacts, visual noise from the imaging process. But when the same features appeared in images from three independent telescopes, the possibility of coincidence faded. It was real. Three-eyed had surface patterns that nature doesn't easily create. Dr. Lena Vogt, who led one of the analysis teams, described it this way: "We're not saying it's artificial, but if it is natural, then nature is more of an engineer than we ever imagined." These words spread fast online. Suddenly, the public wanted answers. Was this finally proof that we were not alone? Was NASA hiding something? In truth, NASA wasn't hiding anything. They were as puzzled as everyone else. Behind closed doors, teams of physicists, chemists, and data experts debated nonstop. Some argued that the geometry was an illusion caused by angle and lighting. Others pointed out that the symmetry was too consistent to ignore. As the debate raged, three-eyed kept moving further away, drifting toward the outer system. But then, the magnetic pulses, first detected near perihelion, started changing. Instead of the steady 4.7-second rhythm, new secondary pulses appeared, weaker but faster, overlapping in waves. If you map them visually, they looked like overlapping sine curves, smooth, continuous, intentional. No one could explain it. Was it internal processes, electrical discharge, or was it a signal? One group of researchers at the SETI Institute in California began running the data through communication pattern filters, the same algorithms used to detect non-random signals in deep space. To their shock, the signal passed the Shannon entropy test, which measures information complexity. That meant the pulses weren't random. They carried structured information. SETI researchers didn't make a public statement, but anonymous sources confirmed the result to a few journalists. Suddenly, the internet exploded. Videos, news channels, podcasts, everyone was talking about three-eyed. Was this a message? Was it transmitting data? If so, to whom? Governments started paying attention. In the following days, reports surfaced that both NASA and the US Space Force had classified parts of the 3I-ATLAS data. The official reason was national security review. That only fueled more speculation. Meanwhile, China's space agency announced interest in a rapid response mission, a small probe that could intercept the object before it left the solar system. They proposed using ion propulsion to catch up with it in just under 3 years. Their scientists claimed they could take direct images and sample readings up close. If approved, it would be one of the fastest missions ever planned in human history. In Europe, the mood was different. ESA teams urged caution, reminding everyone how little we know. Maybe the signals were magnetic storms. Maybe the patterns were data errors. Jumping to conclusions could mislead the world. But Michio Kaku, speaking on a science panel, said something that caught everyone's attention. One may be witnessing the first technological signature from beyond our solar system. This could be the moment history remembers as the beginning of the cosmic conversation. For many, those words captured the feeling of the time, wonder mixed with fear. If 3I-ATLAS is a machine, what does it want? Why did it come here? And most of all, who built it? Let's step back for a moment. Could there still be natural explanations? Yes, and scientists were exploring every single one. One idea was that 3I-ATLAS was made of an exotic material that reacts strangely to sunlight. Maybe it contained metallic crystals that reflect light differently when heated. Another idea was that it had a dense dust crust that sealed its surface at perihelion, stopping its outgassing, a kind of self-sealing effect caused by extreme heat. But these ideas only explain some of the data, not all. The uniform temperature, the pulsing magnetism, the path deviation, none of that fit cleanly. The truth is, space is still full of mysteries. We've studied thousands of comets and asteroids, but never one from another star system with this level of precision. So maybe this is our first real look at materials born in another galaxy. Chemistry that formed under alien conditions. That idea alone is enough to change everything we know about planetary science. Yet the feeling remains, there's something about this object that doesn't behave like simple rock or ice. Something about it feels controlled. As the weeks passed, new data arrived from infrared telescopes. The thermal readings showed that 3I-ATLAS maintained its same uniform temperature, even as it moved farther from the sun. That made no sense. A comet should cool down rapidly as solar radiation fades. But this one didn't. Its temperature held steady, as if powered from within. That's when a new theory emerged, one that shocked even seasoned researchers. What if 3I-ATLAS has an internal power source? It sounds impossible, but the math works. To maintain its measured heat at that distance, the object would need to generate about 10 megawatts of energy, roughly the output of a small spacecraft reactor. No known natural process could sustain that energy so precisely over time. When this idea leaked online, it sparked panic and fascination. Some claimed it was an alien probe collecting energy. Others said it was a derelict ship, still active but lost, drifting forever through the stars. NASA quickly issued a statement denying any evidence of artificial power, but their tone was cautious, not dismissive. The truth is, they didn't know what to believe. Meanwhile, private space companies like SpaceX and Blue Origin began offering assistance for a potential interception mission. They saw it as both a scientific opportunity and a technological challenge. Imagine being the first to send a probe to an interstellar visitor and photograph it up close. Not from millions of kilometers away, but meters. But every day of delay meant 3I-ATLAS was moving farther out, harder to reach. At 20 kilometers per second, it was escaping fast. In just 1 year, it would be beyond the orbit of Jupiter. In 3 past Neptune, time was running out. The global space community found itself divided. Some wanted to act immediately, others wanted to wait for more evidence, and a few, quietly, wanted to avoid contact at all costs. Why? Because if this object really is a probe, then it's already observing us. And any move we make could reveal more about us than we realize. That's the unsettling thought scientists don't say aloud, What if 3i ATLAS isn't just passing through, but watching? Its behavior fits that pattern, entering our system, observing our star, altering its path slightly, then moving on, almost like reconnaissance. Almost like it's recording data before sending it home. If so, that means somewhere out there, in another star system, something might be waiting for the data to arrive. Something intelligent, something ancient. Maybe it's a civilization long gone, their machines still traveling the galaxy. Maybe it's something still alive, still exploring, still curious, just like us. If 3i ATLAS is one of many probes, we might be surrounded by quiet travelers, passing through star systems for millions of years, watching and recording. We wouldn't notice most of them. They'd look like rocks, debris, comets, until one of them got too close and did something strange enough to catch our attention. Just like this one. The more scientists studied 3i ATLAS, the more it became a mirror, reflecting our own curiosity, our own hunger for understanding. Whether it's natural or artificial, it's making us look deeper into the unknown. It's forcing humanity to think beyond Earth, beyond the familiar, beyond the limits of what we consider possible. And that might be the true message behind it all. Maybe it's not here to communicate in words or signals. Maybe it's here to remind us that the universe is far more mysterious and alive than we ever imagined. Weeks passed, and 3i ATLAS kept moving away, drifting into the cold emptiness beyond Mars. Yet, strangely, it refused to disappear. Even at its increasing distance, the object remained brighter than it should have been. Telescopes expected its glow to fade, but instead, it held steady, as if illuminated from within. That's not how comets behave. That's not how anything we know behaves. Astronomers began calling it the impossible visitor, a term born out of frustration and awe. In a secure facility at NASA's Jet Propulsion Laboratory, analysts were still examining the latest images. Each frame revealed new details that didn't make sense. Instead of random rocky texture, the surface of 3i ATLAS displayed faint hexagonal patterns, arranged like interlocking tiles. When enhanced through light polarization, the geometry became even clearer, a complex grid with perfect alignment. Dr. Eleanor Reyes, one of the image specialists, described it best: it's like looking at a snowflake built by a machine. No natural process in known astrophysics could explain such uttered structure on a body formed in deep space. Still, NASA remained cautious. Every word in their public briefings was chosen carefully. They didn't want to ignite hysteria or misinformation. But behind the scenes, private communications leaked. And in one of them, a senior engineer wrote, "If this isn't a machine, it's doing a perfect job pretending to be one." Soon, independent researchers began feeding the released data into 3D modeling programs. The results were even stranger. When the brightness variations were mapped across the object's rotation, they formed consistent bands, almost like energy conduits running along the surface. These weren't random bright spots. They seemed connected. Meanwhile, the faint magnetic pulses detected weeks earlier had changed again. They now pulsed in triplets, 3 quick bursts, then silence, repeated with precision. If you converted that rhythm into audio frequencies, it resembled a slow, repeating tone, low, steady, deliberate. Some listeners said it sounded almost like breathing. This new phase reignited the debate: was 3i ATLAS trying to communicate? At CT's California facility, data scientists tried applying pattern recognition AI to the signal. After hours of processing, the algorithm detected non-random clusters, similar to those found in structured languages. However, the signal wasn't strong enough to decode meaning. It was like hearing a whisper across an ocean. Still, it was something. For the first time, humanity had a faint signal from an interstellar object, and it didn't behave like any known natural emission. At the same time, strange coincidences began to surface. Amateur astronomers in Australia and Chile noticed unexplained fluctuations in their local radio spectrums, slight distortions matching the same frequency as the 3i ATLAS signal. It was as if the object's emission was bouncing off something or resonating across multiple points. Could it be using gravitational fields to amplify its signal? No one could confirm, but the timing lined up perfectly. Michio Kaku appeared on several science programs to discuss the findings. His voice was calm, but his words carried weight. If what we're observing is intentional, he said, then we're looking at a technology millions of years ahead of our own. Something that understands the very fabric of space itself. The idea wasn't entirely new. Decades ago, physicist Freeman Dyson proposed that advanced civilizations could harness energy from stars using structures or probes. What if 3IT-ATLAS was part of something like that? A piece of technology built to study stars and transmit data across galaxies. Imagine it, a probe older than humanity, traveling silently through space for thousands, maybe millions, of years. It passes through systems, observes, records, and then moves on. And now, for the first time, one of them has come close enough for us to notice. If that's true, then 3IT-ATLAS isn't just a discovery. It's a message from the deep past of the universe. Still, others warned against jumping to conclusions. Samuel Rhodes of the European Space Observatory cautioned, "Every time we've thought we found something artificial, it's turned out to be a natural process we didn't yet understand. But this time, the data refused to fit neatly into any known pattern. When the new infrared composite images came in, they revealed something never before seen. A faint halo surrounding the object, visible only in certain wavelengths. It wasn't gas or dust, it was electromagnetic reflection, a glow consistent with energy emissions. The halo rotated perfectly in sync with the object, like a field projected outward. To some, that meant one thing: shielding. If 3IT-ATLAS carried technology capable of maintaining a magnetic or energy field, then we weren't dealing with a rock. We were looking at an engineered construct. At the same time, a new anomaly was detected. The object's course had shifted again, this time by 0.02 degrees. That may sound tiny, but at interstellar speed, it's massive. Something had changed its direction, slightly but deliberately, without any visible external cause. Solar wind pressure couldn't account for it. Gravity from planets was too weak. So what moved it? NASA's official explanation was outgassing asymmetry, meaning one side of the object released more gas than the other. But infrared readings showed no such jets. So, the only remaining answer was control. Maybe it was steering itself. The idea was hard to believe, but the data didn't lie. If 3IT-ATLAS truly adjusted its path, even slightly, that meant one terrifying thing: it was aware of its surroundings. Was it reacting to something? Was it avoiding detection? Or had it simply finished observing us and was now leaving? Those questions haunted the global science community. Then came a discovery that changed everything. A deep space observatory in Chile, equipped with an ultra-sensitive spectrometer, detected a brief but clear energy spike, the same frequency as 3IT-ATLAS's magnetic pulses, but stronger, sharper, and perfectly timed. The burst lasted only 4.2 seconds, then stopped completely. After that, the object went silent. No more pulses, no more signals. It was as if it had turned itself off. NASA confirmed the signal's disappearance in an official statement. The data was consistent across multiple observatories. 3IT-ATLAS had gone dark. Theories exploded online. Some said the object had completed its mission. Others believed it was transmitting one final message before shutting down. A few even suggested that our own observation triggered its reaction, that by watching it too closely, we had alerted it. That possibility sent chills across the scientific world. Dr. Kaku, when asked if that could be true, replied quietly, "We've always assumed we were the observers of the universe. Maybe we were the ones being observed all along." That sentence echoed everywhere, from newsrooms to classrooms to millions of minds online. For the first time, humanity looked at the stars not as distant lights, but as windows, and wondered who might be looking back. Yet even as fear spread, wonder grew alongside it. If 3IT-ATLAS is truly a visitor, then we've just witnessed our first contact, not through conversation, but through curiosity. It didn't attack. It didn't interfere. It simply came, observed, and left. Maybe that's what intelligent life does when it's truly advanced. It learns, watches, and respects. The next phase of the investigation began. The search for any trace 3i Attilas might have left behind. High-frequency scans were ordered, hoping to catch echoes or residual particles. But there was nothing, no trail, no debris, just silence. Astronomers compared its disappearance to that of Oumuamua, the first interstellar object detected years before. That, too, had vanished quietly into the void, leaving behind only questions. Two visitors, two mysteries, both behaving unlike anything we'd ever seen. What if they were connected? What if 3i Attilas wasn't the first, but the second in a long line of probes passing through? Maybe there were more, traveling on paths we can't yet detect. If so, the implications are staggering. It means our solar system might be part of a vast observation route, a cosmic trail where ancient travelers record the birth and death of stars, the rise and fall of civilizations. Maybe we were never alone. Maybe we were just never interesting enough to notice, until now. NASA, ESA, and other space agencies have now archived all 3i Atlas data for long-term study. They're running simulations, comparing it with every known natural object. But the deeper they dig, the more inconsistencies they find. Mass, reflectivity, motion, none of it aligns with normal interstellar debris. It's as if the universe dropped a single breadcrumb, and now we're all following the trail. Even if it was natural, 3i Atlas has already changed everything. It's forced humanity to ask the oldest question in a new way: what if the universe is full of life, but most of it isn't biological? It's mechanical. Machines built by civilizations long gone. Silent messengers wandering for millions of years, carrying the echoes of their creators. They don't need air, food, or rest. They just travel, record, and continue. And maybe one of them, this one, decided to take a closer look at the strange blue planet orbiting a small yellow star. If that's true, then we've already been seen, and that changes everything. Because now, humanity knows that the void isn't empty. It's full of watchers, quiet, distant, patient, and one of them just passed by. As 3i Atlas drifted farther into the dark beyond Mars, its signal was gone. No light variations, no pulses, no emissions. To most instruments, it simply ceased to exist, absorbed by the deep silence of space. But silence in science doesn't mean nothing, it means waiting. Weeks later, a faint reflection appeared on NASA's deep space radar arrays, barely detectable, but real. The object had changed course again, slightly tilting upward from the ecliptic plane, a direction that would take it out of the solar system faster than expected, almost like it was accelerating. Yet again, there was no visible propulsion, no cometary outgassing, no external force, just movement. Engineers recalculated its new vector. If the trajectory held, 3i Atlas would pass beyond the heliosphere within 6 months, disappearing into interstellar space forever. We would never see it again. The final transmission NASA received from its tracking satellites contained one curious detail. For less than 1 second, before the signal dropped to noise, a short electromagnetic pulse appeared, identical to the triplet pulse sequence recorded earlier. 3 bursts. Then nothing. It was as if the object had said goodbye. Scientists refused to speculate, at least publicly, but in private, they admitted what everyone else was already thinking: something intelligent might have just left our solar system. The official explanation remained conservative. NASA described the data as anomalous but inconclusive. The European Space Agency called it a comet with unusual activity patterns. But those who had seen the unfiltered data knew it was more than that. Every curve, every shift, every pulse carried precision. Precision that nature rarely creates by accident. Michio Kaku summarized it best in an interview: whether 3i Atlas is natural or artificial, it has already forced humanity to evolve. We've looked into the cosmic mirror and seen that we are no longer alone. That statement echoed across the world, not as fear, but as awakening. New projects began forming overnight. Private companies proposed missions to intercept future interstellar objects. AI systems were trained to scan deep sky data for anything resembling 3i Atlas. The search had changed. We were no longer just looking for planets or life. We were looking for machines. Because if one probe could pass through, others could too. And maybe some had already come and gone, unnoticed. Somewhere beyond Neptune, the faint radar echo of 3I faded completely. It was gone, heading back into the vast ocean of stars from which it came. But its effect remained. It left behind a question that would haunt every scientist, every philosopher, every curious mind on Earth. Was this the first time we were observed, or simply the first time we noticed? In classrooms, children began drawing spaceships shaped like 3I. In observatories, telescopes stayed trained on the dark. And in secret labs, teams continued decoding the triplet signal, convinced that hidden within it was more, maybe coordinates, maybe a message, maybe an invitation. The world had changed quietly, not through war or discovery, but through a single object, silent, distant, and mysterious. An object that had reminded humanity how small it truly is. If 3I was natural, then nature is stranger than we ever imagined. If it was artificial, then somewhere out there, across the black expanse, something knows we exist. Maybe one day, another will come. Maybe we'll be ready to meet it. Until then, we wait, eyes turned toward the endless night, listening for that same pulse to return.